And I want y'all to try to practice them. These are things that people miss on the test. And I thought we would start off with that. So if y'all just get your notebook, we will pray, and then we will get started on just a few review problems. It'll get your math brain working after you've been doing other stuff. Okay? All ready? Grab your notebook. What else are we going to do? 1, 2, 3, 4, 5. Yeah, okay. Today's verse that I put up, but prove yourselves doers of the word and not just hearers who deceive themselves. That we all need this reminder. We put verses up, read verses. You might have family devotion. You might have your own private devotion. You go to church and you hear Bible taught. In other classes, you may hear people talk about verses like Christian was saying his, was it Latin? Y'all were learning a verse or something. So we hear these things, but we need to make sure we apply them. And that's something I pray about sometimes, and try to, is Lord, would you help me, what you're teaching me, help me to remember it so that I can actually do what you're telling me to do. Like this past week, I heard several messages recently about obedience. And I thought, am I obeying? You know? Remember when you were little and your parents would tell you to do something, and sometimes you just kind of learned you could wait a minute before you did it? Or do y'all have younger siblings that they just kind of wait a little bit? And then your parents are like, you ever heard this statement, delayed obedience is really just disobedience? You've never heard that? It's true. Delayed obedience is just disobedience because you're kind of waiting. You know, and I'm guilty of it. I do it on the interstate sometimes. If I'm riding at 75 miles an hour and I'm like, there's nobody around, right? We're all guilty of it. This is not just a kid or teenager thing. So I needed this reminder, and I thought I would share it with you. So now we're going to pray. Father, thank you so much for this day. Thank you for your word. Thank you that you love us and that you give us guidelines to help us. And it truly does make our life better if we listen to what you say. But you don't stop there. You don't just give us a bunch of commands and say, well, good luck with that. You want to help us. You want to walk with us. You want us to turn to you and ask for help with these things. And I am so grateful for that. And so, Lord, I lift up these students to you. I lift up the ones who can't be here. I lift up Violet and her family as her grandmother has passed away. I pray for Mr. Nelson and their whole family. And I lift up Josiah to you as he's not here today. I lift up all the students who are here. And Lord, you know what's going on in their lives. I don't. I get a glimpse every once in a while of stuff that's going on, but you truly know what's going on with them. So those needs that they have that maybe they're not even aware of, I lift all that up to you. And Lord, for the next hour, I pray that you help us with our math. Thank you, Lord. In Jesus' name I pray. Amen. All right, so I'm going to put up a couple problems. This is just on notebook paper. This is like you're quizzing yourself. These are things that I've seen people miss and I want us to talk about instead of doing a quiz. Now, they're going to look like they have random numbers, but that's okay. I want you to do a factor tree, so I'm going to put factor 360. That's the first one, and then I'll scoot over here out of the way, and you can go ahead and start working on that one. You remember factor trees? Okay, go for it. Yeah, you can keep it, just keep going. Treat it kind of like a quiz. It's not really, but treat it kind of like a quiz. Like you try it on your own and then we'll go over them. Alright, if you aren't quite done, it looks like most everybody's done. I'm gonna go over them and you can correct, adjust. You're checking yourself, okay? There's 1, 2, 3, 4, 5, 6, 7 of them. You can see how many you got right. These are all problems that people missed on the test. Doesn't mean you missed all of them, but they're all problems people missed, so they're things I thought we should spend a little more time. We are going to stop doing the quizzes, at least for now, because I feel like going over the test concepts that you missed is probably better, okay? All right, Billy, how'd you start this one?
180 times 2.
All right, sounds good to me. Okay, it's even, so she knew 2 went into it. I'm gonna do 3 times 60 there. And then I'll do maybe 5 times 12. Did anybody do it exactly like me so far? Probably not, that's okay. But guess what'll happen? It'll end up the same, yeah. So, okay, how many 2s? 1, 2, 3. So 2 cubed times 3 times 3 times 5. Raise your hand if you got that as your answer. All right, good. If you did it, yeah, if you did it different, that's totally fine. Totally fine. You just show how you did it, and that's fine. Kenny, did you find multiplication error in it somewhere?
I think it only got, 1, 2.
You only got 1, 2? Did you leave 4 somewhere? Let's see. Let me look real quick and see if I can find it. Right here, 90 times 3 is 270. So it should have been 90 times 4. That was it. But that's okay, you would have gotten it if you'd done that, okay? So that's just watch your multiplication, double check your multiplication on it. Eli, what you doing? You okay? Okay, I thought you had a question. You almost look like you had a question when you're looking. All right, simplifying, you can actually use factor trees to simplify. Did you know that? Yeah. So you can, or if you see something that both of these are divisible by, you can divide it. Now, I'm trying to think, the divisibility rule for 9, I can't even remember the divisibility rule. Do you remember? I think the 9 one is, yeah, I don't think there's a reliable one. I know 6s are if 2s and 3s both.
Well, I know 100, 9 is the 100. What does it go evenly, but 9 is 9 and 11.
Okay.
So,
Okay. So for this one, if we're gonna simplify it, I'm thinking, this is what I'm looking at. The divisibility rule for 3 is you add up all the digits. Y'all with me? If you add up all the digits and 3 goes into it, then 3 will go into that number. Add 1 and 0 and 5, what do you get?
6.
Yeah, and will 3 go into that? Yeah, so we know that's divisible by 3. And we know this number is divisible by 3. So I'm gonna do 105 divided by 3. 35 over 3. Now, can I simplify that anymore? No, because this is only factor, it's prime. Its only factors are 1 and 3, and 3 won't go into that because 3 plus 5 is 8, and 3 won't go into 8. I could change it to a mixed number. That would be what, 11? And I think that's what Jamie was saying. 11 is 33, and then 2/3. So this is the improper version, and this is the mixed number version. Yes.
I was going to do it that way, and then I found another way to do it.
Okay, what'd you do?
I just did the multiplication 105 divided by 9.
Okay, so you did the division.
Yeah.
Good.
So, and
That's
then,
what I'm
and then I just simplified it from there.
All right, so you did this. And you said that's 11 and 6/9, and then you divided both by 3.
Yeah.
Honestly, I'm agreeing with you. I think that would probably be easier, especially since I had to do a division to do this. If I could do it in my head, then maybe that would be faster.
I did that in my head.
Yeah. Oh, that's fine. If you do it in your head, that's, well, some
Well,
people.
I did the same thing.
Yeah, as long as you did this, yes, that's fine. So as long as you got this. Now, in SAxon 8-7, this is the preferred answer. When you get to Algebra 1, this is the preferred answer. They kind of switch it up on you. They're gonna want you to leave it as an improper. Yeah, I know. Yeah, and there's no reason, but you get to that when you get into Algebra 1. All right, for this one really tripped up some people on the test, okay? This one really tripped up some people. I'm gonna erase this other stuff so you don't have so much to look at here. Okay? What's the problem with this?
Is that it's improper?
Yeah, you've got a mixed number and an improper fraction. So this is the way I think of it. I've got 3 holes, but in here there's enough for how many holes? 1 hole, right? 5/5, and you have 3/5 left over. So it's like you've got 3 holes plus a hole plus 3/5. So what is that? 4 and 3/5. There's your simplified version. You have to think about taking out a hole. But y'all's division method would have worked too. You could have done 8 divided by 5. 1 and 3/5, and then added that 3 to it, which would have made it 4 and 3/5, right? Okay. Not true for that division, but you get that same answer. All right, so I think that's what tripped people up on that. I know what tripped people up on this one. Do you know what most people said? You know, it's like, it's easy. Do you know what most people did? They did 9 and 3/2.
What?
A lot of people will just flip the fraction, okay? Now, If it were 2/3, what's its reciprocal?
3.
3/2. Yeah. But if it's 9 2/3, you have to change it to a mixed improper fraction. Right, so 9 times 3 is 27, plus that's 29 thirds. So what's its reciprocal?
3/29.
3/29. So if you missed that one, that's probably what it was. Maybe not. Okay, had a lot of people miss this one too. I can't remember what I had a lot of people get, but I'm thinking.
Did they do 600 and then do 100?
Yeah, I think they added these two. I think they added to these two numbers. I'm trying to remember, I want to say a lot of people added these two and said 1,510. But if you look, 900 minus 1,510 is not going to be a positive 610. So when you do these equations, my biggest tip to you is check it. Once you get your answer, look back at the equation and say, will that work, right, Eli? I'm asking like, hey, does that work? If I get 2, let's say I get the number 2, is this minus 2 this? No, so then I'm wrong, okay? So, I think a lot of people looked at that subtraction and that messed them up. But actually, you're subtracting the 900 from it. You're subtracting those. Okay, so if we do
290.
Yep. So, watch, but it's not 290, because look. Or actually, I think it is, isn't it?
Yes,
I was looking at the sign and thinking it was the opposite. Yes, so if you do 900 minus 290, you get it. So when you get an answer, try it back in there, and if you check it, it'll help you when you take your test or your quiz or whatever you're doing. All right, when you're adding these, I think this was, I'm not really sure what happened here, but you add your whole numbers, and you can add, or you can do it in a different order if you want. You can add these, they have a common denominator. Okay, right. We can't leave it that way because it's like this other one we did a minute ago. We've got a mixed number with an improper fraction. So 10/7 is the same as 1 whole and 3/7. But we've already got this 11, so that's 12. Okay. Questions on that? Y'all were supposed to work a lot on fractions this week. Did y'all work a lot on fractions this week? That kind of firm it up? Good. I'm glad they are. Now, I've seen this one trip a lot of people up because of the canceling. Raise your hand if you've got canceling. You're like, no, I got canceling. I've got it. Okay. Y'all think you mean you understand it? I've got it. Okay. If you've got it, then good. There are some problems, I think I told y'all this last week, in Algebra 1, that you can't do it if you don't cancel. You have to know how to cancel. So, let's start with when can we cancel?
If they can be divided by 0.
Yeah, so another way to say what David said is they have common factors. What operation can we use? Like when we're adding and subtracting, we don't cancel. It's only when we are multiplying, okay? Now, what about dividing? No, you can rewrite it as a multiplication and then cancel, but you cannot cancel when you're dividing. So let's do what David said. We're looking for common factors. Eli, he said this is easy. Help us, Eli. Tell us what you got.
8 and 8.
8 and 8. How many 8s in there? 1. How many in there? 1.
5 and 5.
Very good. How many in there? 1. And in there 1. You see anything else? That's it. So we're going to multiply straight across. 2 times 1 times 1 is just 2. 1 times 1 times 9 is 9. And that should be your answer for 17. Okay, you may not have missed that one, then that's okay. All right, so that is it. Did anybody come across something in homework this week that you're like, no, I'm not understanding this, that you missed? All right, let me ask it this way. If you had to choose one problem that you never had to see again in your homework, you're doing homework, you're like, oh, that's pretty easy. Oh, no, not another one of these. What is the worst one to have to do?
I would get rid of one that's like so long. It's so stupid. It's like long.
Okay, so it's a lot, right? So it's not hard.
It's not hard. It's just
Like
long.
division?
I don't know.
Just because they're long?
Like I know like somebody will like I just go do quick division, like just put it right by there, you know? We just do that. But like if you're doing a test, like then yeah, but like something like I don't know. I really don't know.
Well, that's something to think about when you're doing homework. If you get to a homework problem and you're like, oh, not another
I
one
want
of
to
these.
do 1+1.
Yeah, wouldn't it be nice to go back to first grade math? Although when you're first grade,
I don't like, well, the things that I don't like when they like say do it in common factorization because those like easier ways.
oh, because you got a different way to do it. Yeah,
Oh,
that
yeah,
makes
I
sense.
know.
Because a lot of things in math, when you first learn it, they make you do it a certain way. But then as you get older, they're not gonna make you do it a certain way. They'll let you pick what you want to do. Yeah. But that's okay. That's a good point. So if you come across things though that you don't want to do because they're hard, let me know what those things are. All right, open your book to 215. This lesson, some of it we'll write down, but a lot of it we're just gonna read because it's a lot to write, and I think you would get more out of it if we just look at what's already in your book. 215, and then the rest of the lessons today we are going to write because they will do better writing. Okay? 215. Okay, what's it about? Metric system. Okay? So why do we even learn it? We're Americans.
Because if we want to go somewhere else, nobody like nothing.
Well, you know, my husband does a lot of mechanicking, and a lot of tools. You have to deal with the metric system, and if you work on foreign cars in America, or even tractors or anything, you've got to use the metric system. Anybody here have a parent or a relative that you know they have to know a metric system because of what they do? Anybody?
Well,
Yeah, you know what? Say again. You can't think of an example. That's
my
okay.
dad was a mechanic and
Okay.
technician, so I mean, yeah.
He probably has to, and he's in America, and we've got to know it. Now, personally, I think the metric system's easier. Now, sometimes the people would, especially older people, will argue with me and like, no way, feet and yards and all that. It's only easier because they've practiced it for so long, right? But yeah, we definitely have a harder system of measurement. The metric system is based on tens, hundreds, and thousands. The American standard system, what in the world? We've got to remember 3, 4, 16, 1,760, right? Feet in a yard. 5,280 feet in a mile.
Why do
Yeah.
they decide to change?
Why did we have it different from the metric system?
Because they want to.
Because the standard system's been around a long, long time, and it's before America. It would have been before America, and I haven't done my history on that in a while, so y'all can research it and let me know, correct me if I'm wrong. But I think it went back, I think in England they used it, like a foot was the king's foot, they came up with the standard measurement. But the metric system is what most of the world uses. Regardless of which one you think is better, you have to do that. Yeah, it was a big foot. Okay, so on page 215, look at the box. Look at the box. Okay, so you see there, it says 10 millimeters is equal to a centimeter, 1,000 millimeters is equal to a meter, 100 centimeters is equal to a meter, 1,000 meters are in a kilometer. If you learn your prefixes, that's pretty easy. Milli just means 1,000th. Centi means 100th. And a kilo means 1,000 of them. Okay? So that's pretty easy to stick it on any of the metric things. And it tells you on the next page, so go ahead and turn to the next page, 216. There's the prefixes that I just mentioned. There's some that we don't use a whole lot of. I don't personally use hecto or deca a lot, but I do use centi, milli, and kilo a lot. Okay, so look down at example 1. 5 kilometers is how many meters? Well, what does the prefix kilo mean?
It means,
Look at the chart at the top. It means 1,000. So a kilometer, it means 1,000 meters. So they're literally saying 5,000 meters is how many meters? 5,000, right? So if you know your prefixes, this won't be very hard, but you're gonna have to memorize your prefixes, okay? All right, turn to 217, that's the next page. Oh, it's almost mine's different. It's a cross run. I tore mine out. All right, so 217, a 2-liter bottle can hold how many milliliters of a beverage? Now, this they're giving you from milliliters and liter. We already said what milli means. What's it mean? Where's your box? 1,000. So it means you cut something into 1,000 pieces. So a milliliter means a liter cut up into 1,000 pieces, and you're only talking about that one piece. Do I? So look at the example. A 2-liter bottle can hold how many milliliters? Well, 1 liter is 1,000 milliliters, so what would 2 liters be?
2,000.
2,000 milliliters. So it's all about the prefixes. And the same thing for the next example. I do want to look at example 4, and it looks like you do have to turn your page this time. Okay. Example 4 I thought could kind of be a little tricky, and that's the temperature differences. It shows you a thermometer there, and it's not in Fahrenheit, what we're used to. Okay? Today it's supposed to be about 81 degrees. Is that Celsius or Fahrenheit? Fahrenheit. Okay, if it was Celsius, that would be good, wouldn't it? Okay, because water boils at 100 in Celsius.
It would be bad if it was 37.
Yes, it would. So let's look at the thermometer here. We know by the thermometer, the way they design Celsius, water freezes at what temperature Celsius? 0, and it boils at 100. That's an easy thing to remember. But in our system, what does water freeze at?
32.
Yes, okay, boys, pick up your pencil, go to the thermometer, and I want you to write a little, beside it, they've got their thermometer here, and they've got 0, and they've got 100, and this is Celsius. I want you to go beside it and say, well, in Fahrenheit, what temperature does water boil? Do you know? I have to look. 212. So Fahrenheit, 212 degrees Fahrenheit is the same as 100 degrees Celsius. Okay, what temperature does water freeze?
32 degrees.
32 degrees Fahrenheit. So put it down here. Just write it right there beside your book, in your book. Okay? All right, so the reason I'm asking you to do that, a temperature increase, look at example 4, a temperature increase of 100 degrees on the Celsius scale. This is talking about this distance from where it freezes to where it boils. That's 100 degrees. What distance is that on the Fahrenheit scale?
That is.
I see you calculating. Some of y'all are calculating. What do you have to do to figure it out?
Subtraction.
Subtract it. Do it real quick. See if you can beat me. Dave's already got it. I saw him start writing as soon as I said it. 180 degrees. So 100 degrees Celsius difference is 180 degrees Fahrenheit difference. So you need to be aware of that when you're reading this. And when you hear, I had this friend of mine, her daughter got a chance to go to Europe. And she went on this, I think she went to Spain and several European countries. And everything was metric system, and they wanted to buy some raisins at this market. And so they were like, I don't know, just a few ounces. Well, they didn't sell in ounces, and it was all in kilograms and grams. Well, a gram is about the weight of a paperclip. Okay, so you don't want to buy a gram of raisins, because you might get like a raisin. Okay? They're like, oh, gee, that's all I get. Okay. But they were like, well, they hadn't brushed up on their metric system before they went, and they ordered a kilogram of raisins. They ate raisins a lot on their trip. So let me just tell you, because that's what the system they use in Europe. Okay, so let's look at, okay, you can close your book and go into your notebook. That was lesson 32. Alright guys, just so you know, we are videoing this for Josiah and Violet, and it's getting kind of, this little noise right here that kind of bubbles under a little bit. Okay? Or else I may have to rearrange or steep. Yeah, okay. Alright, example 1. This is lesson 33. I love that y'all respond when I ask. That's what I need, but just the in-between stuff is what we don't need to do. I want you to arrange these. This is example 1. Arrange these in order from least to greatest. And I'm just going to list them in a random order, okay? 0.13, I'm not even going to read them correctly because I don't want to give you a hint. 0.128, and 0.0475. Order them least to greatest on your paper, please. I want to see your methods. Do you just do the whole thing in your head, or do y'all have a method? You do it in your head.
I do have a method.
You do have a method? Christian, tell us your method.
So just looking at the hundredths, tenths.
Okay, so looking at the place value. All right, so Eli, a lot of times what I've seen people do is I've seen them line it up like this. Why do you think they would do that? Well, this is like what David was saying, I'm not David, Christian was saying, they look at the place value. When you line it up like this, they're all tied for their ones digit, right? Nobody's bigger. You look at their tenths digit, and those are bigger. Now, if, just in case you don't have a picture of this in your head, we have toys. Behind us for the video, I don't know if I'm in the right spot, but we'll see. This is equal to 1. Everybody say 1. 1, okay? So this, actually, you know what? I take that back. Erase that. That's not 1. Let's call this 1. This is going to be equal to 1. Y'all say 1. 1. If this is 1, and it takes 10 of these to make this, what is this?
Oh, a 10.
1/10. Okay? So this is 1, and this is 1/10. Alright, then that would mean, what is this? 100th. Okay, so this is a whole, 1 whole, this is a 10th, and this is 100th. So when we look at this, these two have tenths, but this one does not. So these two are bigger than this. Well, they told us to order it least to greatest, so that means this one should go first. This is the smallest, okay? So then we're just gonna kind of ignore that, because we've already decided that's the smallest. These both have a 10, but this one has more hundredths, so it's bigger. So let's put this one next. And then this one's the third. I also have seen this method where people, and I'm gonna do it with a different color. If this may help you. For those of you that have your own method, that's totally fine. I heard a young lady explain it this way. She says, I just fill in zeros to make them all the same length. And then I say, well, 1,300 is the biggest. 475 is the smallest. I know this is the smallest, and then this, and then this. That's a pretty good method, I thought. That worked for her. So there's a couple different ways to think about it, but that's how you can put them in order, okay? All right, here's example 2. I want to encourage you, a lot of y'all, you've had a lot of math and you know how to do it, but you're a better math student if you can learn different ways to do things. If something's easy for you and you already know how to do it, then take a minute to learn a different way to do it, okay?
Is the square supposed to be like a comparison?
Yes, a comparison. So you're going to compare these two. So you're going to put in a greater than, a less than, or an equal to. So go ahead and do that. All right, Canyon, what do you think? What should we put in there? Got an idea? That's okay. That's all right. Lily, what do you think? Guess what happens if you're wrong? The one over here is what? Is bigger. So we're going to say this is greater than this. So you could use the make them the same length method. This would be 120 thousandths. This is 12 thousandths, so we can see that's bigger. Or you can just compare the place values. This one doesn't have any tenths. This one has 1. It's bigger. All right, let's try example 3. Y'all are going to laugh when you see this. Don't laugh too hard. Y'all ever watch Curious George?
Yes.
Yes, I love Curious George. There was one, tell me if you've seen this one, where he's like, he learned that 0 meant nothing. Do you remember this
Oh,
one?
yeah.
Donuts, wasn't it donuts? Ah, yeah, it's a good one. All right, so he learned that zero meant nothing, and he saw the man in the yellow hat had written a thing for 1 dozen donuts, I think. And he went up and just said, well, since zero means nothing, right? And then they ordered 10 dozen. And so then he decided, wait, if zero means nothing, I'll just keep adding zeros, you okay? So obviously in our play style, oh, hold on, y'all okay? Eli, just get up and get it. You're gonna use, no, Eli, stand up. You can stand up. Walk over there. It's getting further and further from you while you're waiting to do that.
What is it? A pencil pop?
Yes, there you go. Less energy to just go ahead and get it. Okay. So poor Curious George, he knew that zero meant nothing, but a zero before the decimal means a lot, doesn't it? Or when it's between two numbers. Here, I can add zeros all day long, and it's not changing the value of this, does it? It doesn't. And I can add zeros here all day long, and it's not going to change the value. So what do I put in between here?
An equal sign.
Equal sign.
That's why I folded my pencil.
That's why what?
That's why I folded my pencil.
Why?
Because I had it wrong.
You had it
I
wrong?
had it wrong.
You did? Okay.
Your brain.
Yeah, these zeros after a decimal do not change the value. All right, the next thing that we need to talk about, I'm going to skip that example. Eli, you're going to need to come down here, bud. Because come sit right here. Now, because you have to talk to David after everything you do. So come down here and you will get to reunite with David after class. Thank you. All right, example 5. Round 3.14159 to the nearest hundredth. Go ahead and write what you think it is. Do it. To the nearest hundredth. 3.14159. Hey, that's pi, isn't it? It is 3.14159 something.
265.
You know the next one. All right, cool. I didn't realize
It goes on forever.
All right, so go ahead and round it to the nearest hundredth. What digit is in the hundredths?
4.
Yep. So we're gonna look behind it. What's the 1 tell me?
That you round down.
Yeah, just gonna drop it off. So we're gonna say that's approximately 3.14. And that's why we round it, right?
I messed it up.
You did?
I accidentally messed it up, but I actually got it.
You did? Yeah.
So I was thinking the 1 would be ones, 4s, and then 1's thousands, but I just still dropped the 1 off.
Oh, you did? Okay, so it worked out. So you messed up and ended up getting right. Okay. All right, go ahead and round this one also to the nearest hundred. 4396 4315. 4396
To the
4315. Yes, nearest hundred. Nearest hundred.
Oh,
Sorry.
100.
I apologize. I thought it was the same, but it actually says hundred. That's all right. 100. Yeah.
Okay.
All right, Kenan, which digit is in the hundreds spot?
3.
3. And it's interesting because the hundredths is a 3 and the hundreds is a 3. So we're going to look at the 3. That's the one we're going to round. Look behind it and we see the 9. So that tells me to round up, right? Do we drop everything else off?
No.
Well, sort of, but we can't just go to 44, right? These turn to zeros. Okay, so it'd be 4,400 is approximately what that is rounded to the next 100. Okay, what do you think it means when it says round to the nearest whole number? What does that mean?
But when you have a fraction, let's
Okay.
say if it was like 3/4, you round it up, and it goes like 1/4, you round it down.
All right, good. I like how David explained that. Let's look at this one that says to round to the nearest whole number. So he explained it using fractions, but we're going to apply that in decimals. This is 38 and 62 hundredths. Round it to the nearest whole number. the whole number.
3.
Not 3, kind of the whole, this whole thing is the whole number. Yeah, 38. And this is the 1s, the 10s, so those together. So we look at what's after it, and what's the 6 gonna tell us?
Round up.
Round it up. So we're gonna go to 39, and we don't really need any zeros, we're at the decimal, so we'll just say that's approximately 39. Now, the only other thing in this lesson is you round and then you multiply, okay? So they're telling you to estimate them, so you round them first, and then you multiply them. So it's just one more step, y'all will not have trouble with that. All right, the next lesson is one thing that I do see people having trouble with sometimes, so I wanna spend enough time on it. This is lesson 34. Okay?
Do we have to?
Yes, we're gonna write, well, we may kinda write and kinda not, I don't know. We may look at some in here, but first, actually no, this, I think about half of this would be good just to look at, because it's gonna be too hard to draw some of the number lines. So it's 229, page 229. We'll draw some of them, but I think it'd be easier to look. Okay, I want us to read a little bit. Who's got a rested voice and they can read for us a little bit? All right, Christian, you want to? Read us that paragraph under new concept, but first, has everybody found it? Oh, Eli, find it. It's 229. Wait just a second till Eli finds it. All right, Christian, go ahead.
If the distance between consecutive whole numbers on the number line is divided by tick marks into 10 equal units, then numbers correspond to these marks can be named using decimal numbers with 1 decimal place. An example of this kind of number line is a centimeter rule.
All right, I want you to grab, you've got your notebook open, let's pause with the book, keep it open, but I want you to draw a line on your notebook line, okay? Just want you to draw a line. We're gonna draw, try to make them kind of equally spaced. Draw 10 marks, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I kind of made the 5th one a little longer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Draw that. Let's call the first mark you drew 1, and the last mark you drew 10. Okay? That, actually I take that back, I don't want to go 10. We could go 10, but let's change that to 2. Let's look at the fractional parts, because y'all get the number line, okay? All right, so if this is 1 and this is 2, what is this right here?
That's 1/5.
1/10.
Yeah.
Yeah, no,
Oh, yeah.
1/10, 2/10, 3/10, 4. Oh, I should have got one more in here, shouldn't I? 1, 2, 3, 4. I should have had one more mark. Shouldn't I?
Wouldn't it be 1 and 1?
Yes, you're right. David's right, 1 and 1/10. I'm confused too. Hold on. 1 and 1, 2, 3, 4, 5. Let me move my arrow. Let's reboot that. Okay, so my point in asking what it was what are each one of those? Each one of those is a 10th. Okay? But David is right. This one is 1 and 1/10 because it's between 1 and 2. Okay? Now, that's a mathematical construction. We drew a number line. Y'all draw number lines, and I know you get that. But you actually see this just like this on a ruler when you're looking at centimeters, right? All the little marks, well not all, but the bigger marks are tenths, right?
Yes.
So, that's what this lesson is going to talk about. Number lines, and then they're going to relate it to rulers, okay? Now, look back at your book for a second. Example 1. Y'all see it?
Yeah.
Find the length of this segment in millimeters. Okay, now we just talked about how these are tenths, right? Those would be tenths of a centimeter. It's kind of like we enlarged the ruler, and this is 1 centimeter. okay? So that, if that's 1 centimeter, this is 1/10 of a centimeter, which is a millimeter. That's kind of confusing, isn't it? Okay, so millimeters are the little tiny ones. Okay, so look at A. How many millimeters is that line that they drew? Say again? Okay, what is it?
23.
All right, 23. It's just past the 2, but we know there's 10 marks between each whole number, right? So that's 10, 20, and then like David said, there's 3 more, so 23. All right, but what if you were going to do that in centimeters? He said that's millimeters. Centimeters are bigger units of measurement, so you're going to have fewer of them. What would that be in centimeters? 2.3 centimeters. 2.3 centimeters. Okay, so look at this picture. Look up at mine and then look down at yours when you find it. Y'all looking at the picture? Okay, so you see the line goes past the 2, but not all the way to the 3. So that's 2.3 centimeters, but it would be 23 millimeters. So this lesson and the metric lesson, they're going to be related a little bit. Okay? All right, turn over to the next page, example 2. We're going to write this. Find the perimeter. Well, you got to remember what perimeter is. What's perimeter?
It's the area, the distance around the entire.
Yes, distance around, all the way around. The perimeter is that distance. It's the blue that you see. What's area?
Area is
Length times width. It's covering it. So the green is your area, right? Perimeter is just distance around. So look at example 2. Find the perimeter of this rectangle, but that's easy. Y'all been doing that for a long time. But it says in meters. What measurements are they giving you? Centimeters.
Find the area or the...
No, it says the perimeter. So when you find the perimeter of this, we're going to do the work in our notebook. How would we find the perimeter in centimeters?
Well, like,
Couple different ways to do it.
Meters,
But don't convert it. Well, I guess we could convert it.
Well, just
First.
find out how much.
Yeah, you're right. I shouldn't have stopped you because that's one way to do it. My brain was thinking do it and then convert. But if you want to convert it first, that's fine. So Christian is saying, let me draw my picture here. This one is 12. This one is 7. Christian said, well, hold on. Let's change that to meters. Well, centimeters are little tiny things, right? And a meter is really big. So if you've got 12 centimeters, that's not even a whole meter, is it?
Wait,
A centimeter is 1/100th of a meter. Yeah.
I think I know an easier way.
Okay, well, let's finish it Christian's way, and then we'll do it your way too. So that'll be good.
What I would do is just add them both first in centimeters
Okay.
and make it 19.
Okay.
And then I would convert it into meters, which is 0.9 and 0 and 19.
1900.
Yeah.
Yeah.
Of
So you convert in the middle because this isn't our whole perimeter. This is half of our perimeter.
you got 12 and 2 12s.
Okay. So you added, all right, so look, Christian added this and this. How about let's double it? So we can get the rest of the way around, right? 38 centimeters, right? Once we have that, he says, well, I know it takes 100, hear me what I'm saying here, you ready? It takes 100 centimeters to make a meter. I'm gonna write that down. 100 centimeters equals a meter, okay? That means if I have 38 centimeters, that's out of 100 that I need to make a meter. But we're thinking decimals, so I would write it 38 hundredths of a meter. That's the perimeter of this in meters, 38 hundredths of a meter. So you could have changed it right here and said that's really this number of meters, whoops, that's 7. And that's 7, not 7/10, 7 hundredths of a meter there. So 12 hundredths of a meter, 7 hundredths of a meter, and then done the calculations. Or you can calculate the perimeter and then change it. That's the 2 ways I was thinking. Dave, did you think of a different way? All right, what are you confused about? Did I mess up?
Because like 12 centimeters, okay, well, if you find the minimum on F, in centimeters, it's gonna be 38.
Right?
But 38 so long. Is the answer 38 is gonna be the same thing as the other answer. So like how come it's
Third.
Oh, okay, I think that's what you're saying. This, or maybe not, tell me if I'm getting it. This is 38 centimeters. And then with here, we changed it to meters. That's 38 out of 100 that I needed for a meter.
And there's 100.
So there's a decimal there. So they're not the same, they look kind of the same. But any conversion in the metric system is basically just moving the decimal. Okay? So this is 38 centimeters. And remember, it takes 100, I wrote 1 centimeter equals a meter.
Yeah, I didn't want to interrupt you.
Oh, you can interrupt me for that. I said 100, but I wrote 1. I'm not really sure why that is.
I think I know why we're confused is because you're doing the American Standard System.
Yeah. If we were talking about feet and inches, we could get this. But
the two answers should be like the same, right?
no, they shouldn't be the same because this is
They
in
should equal the same, right?
No.
Oh, then they should, 38 centimeters is 38 hundredths of a meter.
Yeah,
it is the
they're
same.
equal.
So I don't
It's just me.
Well,
Because meters are bigger than centimeters.
yes. So 38 centimeters is not enough. Okay, here's a picture.
I was thinking the opposite, like a meter is
Oh, I see. Okay, I was going to say, if you let this represent, well, actually, this might be better. If each one of these things was a centimeter, how many would it take to make a meter? How many would it take? It takes 100, but how many of those? These are sticks of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so if I put all these together, let's say we're going to let that represent our meter. Okay? Now, we had 38 centimeters. So that's like 10, 20, 30, that'd be about right here. So that's not enough for a whole meter. So it'd be 38 out of 100. Does that make sense?
Yeah.
Yes. Okay, I'm glad you asked. I appreciate that you asked. And sometimes a visual helps more than anything. You like my stuff? I got these at a curriculum sale. I was pretty happy. And it was on the last day, but it was 50% off. So that was really happy. All right, let's look at example 3. This is a number line one. Find the number on the number line indicated by the arrow. We're not going to draw it because that's going to be hard to get it to work out because I had a hard time on it. All right, solution underneath of there. But let's see if we can do it without looking at the solution. Look at A. A is between what two numbers? 4 and 4.1. Is it halfway in between them?
Yes.
What would be between 4 and 4.1?
4 and
It's not 4.5.
it's 4.15.
4.05. That's right.
Oh.
Yes, 4.05. Okay, because it's going to be halfway between the 4. Now, one way to think about that is you could do, let's say, we know it's between this and this. And you could add another 0 to it like that. And so what would be between 0 and 10? Well, it would be that. That might be an easier way to think about it, is to add a 0 so you can think about the number between it. All right, let's look at B. It's between 4.3 and 4.4, right? All right, so if you think about that as 4.30 and 4.40, David, what do you think?
4.38.
Okay, because it's on the 8th one. So that's going to be like 31, 32, 33, 34, 35, 36, 37, 38. Yes, before you get to 40. All right, and then the same thing with C. All right, 4, you're starting to add them. That's going to be the same as when you do perimeter. Same thing. All right, let's look at lesson 35. We're almost done. Almost done. But I think Christian's probably right. Even though we say, oh, the metric system is easy because it's got easy numbers in it, it's still hard because our brains think the other system. Just like when the girls bought a kilogram of raisins. Okay? They weren't thinking they were going to get that many. So it's hard for us to think it. Alright, less than 35. Alright, try this one and let me see how you do. Example 1. 3 6/10 plus 36 hundredths plus 36. Go.
I got it.
Got it?
Oh.
You were just right.
I wrote it down like I couldn't do it. I was like, I don't know.
Did you line them all up like this?
Yes.
Okay, where's the decimal in 36? It's at the end. Yeah, we don't have to write it when we write 36, but it's at the end, so I needed to bump it over. So look at your paper. Did you bump it over? If you didn't, fix it. That's why I wrote it out this way, like the book did, so that we could see, did you know how to line it up? All right, so what numbers are here?
Zeros.
Zeros, and you can write them or you don't have to. When you subtract, I would especially think you need to write them in, because especially if you're borrowing, but adding, it doesn't matter. Your handwriting has to be good enough that you line them up, though. Okay?
I mean, yeah, that's what we kind of have to have the zeros there.
Yeah.
People would be like,
Yeah. But for this, I think it's okay to add it out. But yeah, subtracting them, definitely put them in there. So you should have gotten 39 and 96 hundredths.
Forgot it was a multiplication.
Oh, you were thinking rules for multiplying?
And
Okay,
you got
we
the
will
right
do that later, but today we're just gonna do the adding. Or no, actually, we are gonna do some multiplying, I forgot. That is part of this lesson. All right, so this is kind of just everything decimal.
I just noticed,
Yeah,
but at the bottom corner, it tells you the answer.
it does, yeah. On all the lesson ones, it does. All right, so example 2, add these up. That's why I always tell y'all to shut your book when we're doing one that I'm
I
gonna
was
do.
even on it. I was
Yeah.
like, wait,
It's
where?
fine, it's fine. So add 1/10 and 2/10 and 3/10 and 4/10. You might can do this one in your head.
Yes.
Yeah.
Hopefully. You're so right.
Alright, so 1 plus 2 is 3, plus 3 more is 6, plus 4 is 10. 10 tenths, how do I write that?
1.
It's 1 whole, okay? And if you added them up and aligned them up, you would get the 0, carry the 1, but you can just write it as 1. Okay, how many people just got 1? Right, looks good. Alright, example 3. This is a subtraction one, be careful. 12 and 3/10 minus 4 and 567 thousandths. 12 and 3/10 minus 4 and 567 thousandths.
67.
12 and 3/10 minus 4, 567 thousandths. I'm just gonna change your borrowing just a bit. Alright, so, and notice that some of y'all forgot to put your zeros there and messed up your borrowing, so be careful, you do need some zeros there, because you're not just bringing these down. This is 0 minus 7. Every time Benjamin says to me, well Mom, that's just 7. I say, no, put 0 fingers up, now take 7 down. Right? And he'll go, I can't. Oh yeah, I gotta borrow. That's what he says every time. Okay, so you get 0 minus 7, you can't just put the 7 down. So we're gonna go over here, this one's gonna become a 10 and a 9. This one's going down, this one's going, I need it all the way across, Donna.
Whoa, that is weird.
What was weird?
It's just,
That's what I did.
that is not what I did.
That's not what you did? Did I mess up? Okay, I have to borrow
No,
from
you
here.
didn't mess up.
No, I didn't. Okay, so that was 10 and it goes to 9.
Yes.
This one went down and then this one was 1, but then I have to take that one and that one's 11, right?
I did it all wrong, the way not
I
like
don't
off the
know.
top
I
of my
tried to make
head.
that a 12.
That's what I was thinking.
There we go.
Well, I'll just stop. I'll stop at the 1, and I'll take away the 1 to tell them 0, and then the 2 make it a 12.
Oh, you start from, you go left to right.
I do it.
Okay, so 7 and 733 thousandths. Okay, so the biggest tip on these when you're subtracting them, just like a minute ago when I said this addition, you didn't have to put these zeros in if you didn't want to, you just have to line the decimal up. Well, with subtraction, you need to put the zeros in, because it'll help you remember that you need to borrow. Okay, all right, here's another one kind of like that. This one is example 4. 5 minus 4 and 32 hundredths. 5 minus 4 and 32 hundredths. This one I think is helpful to think money. That, to me, decimals make a lot more sense if you think money rules. You just do this. Alright, so we're gonna put zeros in here. Remember to put your zeros in. And then when I borrow, this one, I always used to tell Benjamin a story. I would say, well, this one doesn't have anything, so he goes to his neighbor. His neighbor says, sorry, bud, I don't have anything either. He goes to his neighbor, he's like, okay, I'll give you one. And so then he takes it, and then he's like, okay, now I got enough to let you have it. Right? That's the story I used to tell Benjamin. Alright, 10 minus, he doesn't need that anymore. 10 minus 2 is 8. He can give out of me if he thought. 6, and then that's it. So what's here? 0. So it's kind of like $5 minus $4.32. Okay?
That's what I like.
What time do we get out?
I think it's 2:10.
I thought it was,
That is a
Yeah.
weird
I thought it was 2. I was like, it's 2 or something.
Because the next class is at 2:15. So it's between 2:10 and 2:15 for the others that come in.
Yeah, I was just thinking because usually like classes get out like at 2:15.
Oh,
I
okay.
thought that's what I was thinking.
Yeah, it is sort of 2:15, but then there's a transition there. All right, I want you to multiply these two because, like Eli said earlier, the multiplication rules are different from the addition and subtraction rules. So I want to make sure we get to these before we go. This one's a long review lesson. Okay, do you remember how to do them?
Really?
Yes.
All right, let's just do this. We'll do this together. If you work ahead of me, be sure and check it. When I multiply decimals, I just put the longest, not necessarily biggest, but longest one on the top. You don't have to line up the decimals, okay?
That's usually what I do.
Is that what you do? Okay, and then I multiply. 4 times 3 is 12, carry the 1. 4 times 2 is 8, plus 1 is 9. 0, and then I add a 0 just like you normally would, but the next number is just zeros, guys. Shh, the rumbling, don't rumble. The next number is I'm multiplying by 0, so I don't need to add another row down here. I can just count the decimals. There's 1, 2, 3 behind the decimals, so I go 1, 2, 3, and that's where my decimal's gonna go. So multiplying, you're gonna count the decimals to figure out where to put. Now this one I am going to get you to do by yourself. Do this one. 35 times 4 tenths. 35 times 4 tenths. I'm going to do it up here and kind of hide it. Y'all write it down?
Yes.
Sort of hide it. And then you can look up here and check it.
How many are in the problem? How many are just behind the decimal in the problem? One. Yeah, you only move it the number behind the decimal.
That's good. Okay, I see several of y'all have gotten it. Does this number have any numbers behind the decimal?
No.
No. This one does just 1. So in your answer, you're just gonna come in 1. So your answer is 14. Okay, those are just, you're just gonna have to practice them to remember. And these are all things you've learned before. All right, I wanna do one of the division ones in our last little bit. They're only gonna be divided by whole numbers, okay? So write this one down with me. 5 into 3 and 425 thousandths. 5 into 3 and 425 thousandths. Okay? You do it like normal. This week, they're not gonna throw any dividing by decimals. 5 won't go into 3, so I put a 0. 5 will go into 34, what, 6 times? 6 times 5 is 30. Bring down to 2. 5 will go into 42, what is that, 8 times?
Yeah, but I don't know where to put the decimal.
Oh, good question. All right, we'll bring down to 5. 5 will go into 25 5 times.
There we go.
All right, so when you're dividing by a whole number, the decimal just comes straight up. That's the easy ones. Those are the easy ones. If we're dividing by a number that has a decimal in it, then we have to adjust it, and we will get to that later. Okay, right now, it's just bring it straight up. Bring it straight up. Okay, did you get it? Yes? Eli, did you get it? Uh-oh, where'd you do your division? Oh, yes, you did. All right, good. Good. Yes.
No, it's there.
Oh, it's down below. I got you. You got it. Okay. That is it. Make sure you're doing the lesson practice. Do you see this little star? Hold up for a second. Y'all see this star? And on the video, y'all see the star? The practice set, when it has a star, do you know what that means? No. There's extra practice in the back. If there's something here you're having trouble with, you may need to do the extra practice, okay?
In the back.
Yeah, I think it's in the back of it. Or it may be in the teacher book. Let me look real quick.
I think there's stuff in the back.
Yeah, I think